Hello everyone, in this video let me explain to you Kruskal's algorithm with an example. The objective of Kruskal's algorithm is to find a minimum cost spanning tree from a given graph. If there are n vertices in the graph, the number of vertices in the spanning tree has to be same as that of number of vertices in the graph. Number of edges in the spanning tree should be 1 less than the number of vertices. That is, if there are n vertices, number of edges should be n minus 1. In a spanning tree, there should be no cycles. Also, the cost of the spanning tree should be minimum because Kruskal's algorithm is a minimization problem. Now, in order to find the minimum cost spanning tree, you may also arrange the weights of each edge in ascending order or increasing order of weight so that each time you pick an edge, it will be easy for you. Now, whenever you add an edge to the spanning tree, please make sure that it doesn't form cycle. If it forms a cycle, you cannot add that edge. Now, we will see this with an example. Here is an example graph given with 7 vertices and weights are associated with each edge. Now, we know that a spanning tree should also have the same number of vertices as the given graph. So, let us say it also has 7 vertices because in the graph we have 7 vertices. Your spanning tree also has 7 vertices. Now, either you can arrange all the weights in increasing order or you can pick the minimum weight from the given graph. From this graph, the minimum weight is 10. So, that is connecting two vertices 1 and 6. So, as a first step, let us choose the minimum weight and add it to the spanning tree. So, the weight with 10, which is connecting 1 and 6, is added to the spanning tree. Now, after 10, the next highest weight is 12, which is connecting 3 and 4. So, let us add 3 and 4 to the spanning tree. So, as of now, we have two edges. One is connecting vertices 1 and 6. The second one is connecting vertex 3 and 4. So, the weights are 10 and 12 respectively. Now, since we have considered 10 and 12, let us consider the next highest weight in this particular graph that is given here. Now, next weight is 14. So, that is connecting vertex 2 and 7. So, we have the edge connecting 2 and 7 with weight 14. Next is with weight 16. So, I am connecting 2 and 3. 2 and 3 is connected with 16. Each time you are adding an edge, make sure that it doesn't form cycle, because according to the definition of spanning tree, we know that it is a tree with no cycle in it. Now, after 16, the next edge with higher weight is 18. Now, if I add this edge 18 between 7 and 4, if I add this edge, it will form a cycle. So, since it forms a cycle, I cannot add 18. So, I should choose the next higher weight, that is 22. Now, add an edge between 4 and 5 as 22 with weight 22. So, I have added here. Note that the next higher weight after 16 was 18, but 18, if I add 18, 18 will form a cycle. So, here between 7 and 4, if I add 18, it will form a cycle here. So, I should not add 18. Go for the next higher weight, that is 22. So, I am adding an edge between 4 and 5, which is of weight 22. After 22, which is the next higher weight, 24, right? So, if I add 24, that is between 7 and 5, if I add 24, it will again form a cycle. So, I cannot add this edge which is between 7 and 5 with weight 24. So, I ignore that, go for the next one, that is 25 between 6 and 5. So, I add an edge between 6 and 5 as with weight 25. The next highest order of weight is 28. After 25, it is 28. If I add 28, 28 is an edge between the vertex 1 and 2. So if I add an edge with weight 28 between 1 and 2, again it forms a cycle. So I cannot add this edge. So we have checked with all the edges in the given graph and we got a spanning tree. And let us check if it is a spanning tree. We said that when we are finding a spanning tree from a given graph, the number of vertices should be same as that of the given graph. Now let's see what are the number of vertices here. 1, 2, 3, 4, 5, 6, 7. There are 7 vertices in the given graph, and even in the spanning tree we have 7 vertices. Number of edges should be 1 less than the number of vertices. That is, number of vertices is 7. So number of edges should be 7 minus 1, 6. Let us see whether we have 6 edges here. Here is a 1 edge, second, third, fourth, fifth, and sixth. So it is satisfying the condition of a spanning tree, saying that number of edges should be 1 less than the number of vertices. Now, third case, there should not be any cycle. There is no cycle in this graph. Fourth case, it should not be disconnected. It should be a connected graph. So it is a connected graph connecting all the vertices. So this is the spanning tree, and the minimum, it's a minimum cost spanning tree. You can also mention the total cost of this spanning tree. That is 10 plus 25 plus 22 plus 12 plus 16 plus 14. Yeah, that's all for about Kruskal's algorithm. One thing we have to remember, that Kruskal's goes in a disconnected way. That is, finally you get a connected graph, but in between, if you see the stages, you will have a disconnected graph, which is leading to a final graph. Whereas the Prim's algorithm, which we have learned in the previous session, it goes as a connected graph. Every stage it is a connected graph. And in Kruskal's, whenever you are adding an edge, please make sure it does not form any cycle, and the number of vertex should be same as that of the graph. Number of edges should be 1 less than the number of vertex. The total cost should be minimum, since it is a minimization problem, and there should be no cycle. That's all for Kruskal's algorithm. Thank you so much.